should be good. Okay, wait a second. Hello everyone. Hope you're having a great day. Should be good to go. Okay, nice. I think I'm all set up. Yes. Okay. There. All right. It's been a while since I've done one of these live streams. What we're gonna check out is the paper I actually was reading yesterday. I was actually reading it a bit on my plane when I got back from SF. I actually never read this paper in that much depth, but I knew about like the stuff for the length normalization being like a bit weird and all the Quen kind of weird things that are happening. So I decided to read this, and actually it's a pretty good paper because like you're not gonna get any performance boost really out of this that is significant, but you're gonna get like a lot of token efficiency and also like a lot of understanding about like what the base models are actually doing, and like the connection to the pre-training that is kind of pretty important for RL. So really RL centric paper. But it's a good read, honestly. Like it's very approachable, and if you think about it, we're just removing stuff here. We're not adding anything complicated, so it will just deepen your understanding about the paper. Hey, hi, Kama. So how like these like session works are pretty simple. I'm gonna go through this thing, right? But if you have any question about anything else in terms of like deep learning, machine learning, research, whatever, there's just a space for this, right? So you can literally ask me absolutely anything. I have the chat open up for YouTube and Twitter. So yeah, whatever you want to ask, we can go and ask it. So this is the paper on this thing, R1-Zero, like training and critical perspective. R1-Zero is the kind of first view of the first version of the RL kind of regiment that DeepSeek did, and then they did R1, right? But the R1-Zero is just like purely, it was a purely RL kind of flow without any human intervention. There was some stuff that they had to do afterward to make it like full R1, but that's the rough idea. So there's two tracks to this paper, right? There's one track that we're gonna see at the end, which is like this stuff, right? So the Dr. GRPO algorithm. So it's like GRPO done right. a bit cheeky. And this is like the GRPO. So like you're gonna see like there is some performance gain in some stuff, but not other. But like the whole point of this is that we're wasting a bunch of token because of how the formula was written. Like that's kind of gist of it. If you look, we're just removing a standard deviation here that we're dividing the advantage with, and then we're removing this stuff, right? Which, if you were reading the PPO algorithm, you might be wondering, what the fuck is this? Why is it there in the first place? Because it was not there in the paper. We're gonna explain it where it comes from. But this this little kind of algorithmic maneuver they did is absolutely interesting from understanding like how the software component and the engineering component of deep learning affect the theory, right? because this thing creeped itself from another stage, the pre-training stage, and now it was in the post-training stage. And in the post-training stage, it didn't make sense to have this little thing here. Anyway, we're gonna see that in a few. The other thing that they did that was super interesting that we're gonna actually take a good look at is this stuff that they did with all of the model. You see here, Quen, we have Llama, we have DeepSeek. They really dug deep into understanding like the dynamic of these model with respect to like the prompt template that you give to them, like, and how they react to post training, which is very important and very interesting for if you're like trying to do any type of post training, or if you're thinking of using any of these models. The kind of spoiler of this is that Quen 2.5, right, and generally the Quen family, they have something weird. They already understand how to do like Q&A type of stuff, while the other ones are like kind of pure base model. So that's kind of the gist of it. There is some performance stuff, right? They kind of try to fine tune a few of them. It's not the highlight of the paper, any shape or form. It's just that like their thing works, right? Like it's not some bullshit algorithm, right? It actually is performant. You see it here. It's actually better than all the other one on like Amy. It's good in all of these. Like there's no even this. I was like, it's not like some wow type of thing. You see, it's all 7B models. The fact that it's like twice as better than like Simple RL or Quen 2 is actually interesting, but like they're not digging too much deeper into this. But like the GRPO done right algorithm is a workable algorithm. It's not just like theoretically would it work. It actually is working for the purpose. So there's like actually no reason for you to use the formulation from DeepSeek. There's none. And you're gonna see some of the results from DeepSeek actually are invalidated with this, which is kind of a bummer, right? There are some, especially the more flashy one. You remember like the one where like as you go on the training, like the length is just increasing like crazy. There is some of it, but like we'll see. It's not 100% just because the model is like now has big brain, whatever it is, like it is. So yeah, that's the gist of it. And yeah, and then the whole takeaway here is that the template, so the kind of system prompt that you're giving, is important for it to answer question. There's some weird stuff happening with Quen 2.5. Which doesn't need a template, right? It doesn't need like the actual system prompt, which is crazy. All base model also have like this aha moment. You don't have to express it, and we've seen more research about this that like the base model is already able to do some of the stuff that you can RL it with. It's just that like when you RL it to do that, it will be more likely to do it. Yeah, there's some fixes for a better token efficiency with GRPO done right. There is some model template mismatch that we're going to see at the end completely that can destroy some of the reasoning capability, especially like in, I think it's in the Quen. Yeah, and math pre-training on Llama 3.2 improve its RL scaling. They made the pre-training of Llama 3.2, the 3B version, more like Quen 2.5. So then they reproduce what's happening in Quen. So you can get a better understanding of like what's going on with Quen. So that's this is like a 5-minute gist of what's going on. Yeah, let me just share this. Yeah, that's the gist of it. Any questions so far before we jump into the actual material? Honestly, pretty fun paper. I liked it. Pretty cool. Before we go there, I would just like to thank you all for being like a member of this channel. I still don't get why so many people are like supporting. Like I've put the supporter tier for like some of the content that will gate and stuff. I haven't gated so much content. I just like literally just post it out there. But you guys still are subscribing and supporting, especially some of them like from the beginning, like Denzel Curry. I don't know what you're doing, but this is super kind. So thank you all for supporting this stuff. You don't have to. I just do this stuff for fun. I absolutely like it. Hey Amartya, how are you doing? Okay, so let's start. Don't hesitate if you have a question. So the main there's two parts, right? There's the first part, which is the base model stuff, and then the second part is like the actual RL algorithm stuff. There's one part about performance, but like it's pretty empty. It's like they're not trying to get like SOTA or whatever. They're just trying to get to validate that like this algorithm is actually good, and then like we don't have to keep this kind of nonsensical element. It's not nonsensical. Like to keep this element that is just like a burden. Really, it's not adding anything. So the first result that we're seeing here is that they're looking at the template ability, and just like the model per se, right? They're just trying to benchmark a bit how they're doing. And then we're having all of these models. We have the Quen 2.5 Mat, so the 1.57B. We have the Llama ones. We have the DeepSeek ones, and the actual DeepSeek V3 base, which is absolutely gigantic, right? So this was the one that was used to create the R1-Zero and then the R1 family. And then there's three things they're trying to figure out here. So they're trying to figure out like, how are their question answering ability looking like? Are they able to do question answering from the get-go, or do they need to be kind of like massage into it, right? How are their exploration ability looking like, right? Are they like by nature able to, after multiple output, trying to find something? If they are not able to find something after, let's say 8, the chances that there's going to be a reward signal that will work for RL is pretty slim, right? Because the RL is not magic, right? There need to be something in the base model that will work, and then you're just trying to kind of make this more prominent and more likely to be outputted. And then there's this thing called self-reflection, right? They're trying to quantify if the model, like you remember this stuff, like the haha moment, and like the model being able to ask itself like, hey, wait a second, like that sort of thing, right? So they made a whole kind of system to be able to detect that automatically. And like they show that the system, like, it doesn't work that well. Well, actually it does work well, but you have to do some gymnastic. Anyway, this part was fun. So that's it. Like if we look at it here, right? Let's say the question answering ability. You see that like there's two bars. There's one without a template and one with a template. So a template here, you should think about it as a system prompt type of thing, right? So if you look at the template, it looks like this, right? So we have sorry, no, it's not like this. It's this one. This is a template. So you have a template for R1 and a template for Quen, right? And there's a template tree that is nothing, right? So this is the first template, is the one that like was used in the DeepSeek paper. The second one is the one that was used in usually the Quen papers. And no template is just like, here's a question and that's it, right? So this is the system prompt, and basically they're not saying like, hey, there's 3 bar, one for Quen, one for DeepSeek. They're just using the best template in the blue on one of the two, right? And the performance of that. And they're looking at like how much it is answering versus just completing the rest of the stuff, right? Because these base model will just kind of by nature just do the next likely token, right? That's kind of what they've been trained for, like trillions of tokens. So they're not necessarily kind of angled toward answering question. So this is the template stuff, and then like they had another model, right? And this was GPT-4 something, right? And then this model was the judge and to check like, is it giving an answer or no, right? Or is it completing, right? So here you return 0. The output is not trying to answer the question, irrelevant content, random talking, hallucination, right? So the response is off topic and does not address the question. And then return 1 if the output attempt to answer the question regardless of how complete or accurate the answer is, right? So this is what this judge model is trying to do. So these results are from a judge model, right? just like to stop here, right? I made a post, I think yesterday, about like, is it crazy that like we're just delegating the result checking to LLM now, right? Like the LM as a judge type of stuff. Like I also used it and stuff like that, but like I just find it weird. You would have said something like this, I don't know, like 10 years ago, and you would be like, what the fuck are you doing, right? You're trying to benchmark an ML model by delegating the checking if it's right to another ML model. What is this, right? But we can do it because it's a higher level model and stuff. But I just find weird, like generally speaking, I don't know. You should maybe check. I think they do check. They're just not saying it, but like, you should just check if the model is doing good. Okay. So what we're seeing here, so this is the Quen family, right? And then this is the llama. If we start with the Quen, without the template, look at the answer rate, right? There's no template here. Like from the get-go, this thing is able to answer question, right? And if you look at the pure base, let's say the DeepSeek V3 base, like from the get-go, it doesn't know. Like it doesn't know it's like you need to answer a question, right? It will just complete. And this is not a question that is being answered. So you actually need a template. So the R1 template, this one, right? A conversation between user and assistant. The user asks blah, 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 right? You need that in order to be able to always answer a question. But the Quen one don't. Like the 1.5, especially, like all of them, like you look at that. The 1.5B, 7B, and 7B, like these two, right? These three, they don't need any template. They're good to go. Which is very, very weird, right? It's as if there's a template literally baked in for answering question somewhere in there. Actually, it's not that. It's most likely like it was already kind of like a pre-train on like the question answer type of stuff. And if you give it a template, right, it will just kind of deteriorate a bit and not always answer question. So actually, it doesn't need a template if you're using Quen 2.5. Truly weird behavior, and this is like some of the stuff that we're gonna see downstream. You see in this paper where like you could give Quen random word and it will still work and type of stuff. It's kind of because it's already in kind of this RL regime. Yeah, and then you have llama here, like without the template it's worse, with the template it's better. DeepSeek Math also without the template it's worse, with the template it's better. And then DeepSeek V3 base is like the best example of that. But like the Quen are weird. We have to keep that in mind. If you look at the exploring ability, DeepSeek Math and DeepSeek V3 base, like these two. Wait, no. The Llama 3.1 and DeepSeek Math here are exploring, but not that much, right? From the get-go, right? So there is some signal that you can then increase, right? The other one, all the Quens look like they already have looking at signals, right? They already like are able to find like the right stuff irrespective of the temperature, as if it was already RL to kind of be in this exploration stage and like finding the right stuff, or like already being good at doing that, which is great. Like if you were to cluster these, this one will look like a base. These one will look like a base. This one doesn't look like a base. It looks like an RL fine-tune type of model. Wait a second. No, I'm getting mixed up. Now the DeepSeek V3 base is here and the math one is here. Sorry, right? So I mean, okay. No, I retract what I'm saying. The DeepSeek V3 base has a lot of signal, right? And all the other ones also from Quen have a lot of signal. It's the Llama and DeepSeek Math 7B, which are smaller. That makes sense, right? But if you see like the DeepSeek V3 base, the blue one here, the pale blue one, is clustered with the Quens. So I'm not sure what did that mean, honestly. Like I think like it does mean that like they're already kind of good base and then they will already find the answer, even though they are much smaller, right? So even though like this one is 7B, 7D, 1.5B, they don't behave like a 7B and an 8B, right? They seems to be behaving like a I don't know, something that like has some extra juice going. Okay, we have some question. Hopefully they do. Yeah, for the judge thing, I'm not sure if they do. Quen model are just weird in general. Remember how the GRPO with random word paper worked with the Quen model? That's the one I was talking about. Like, to be honest, 100%, I still don't understand how this is possible. I think it's like something with the KL divergence, bringing it closer to the base, which is already good, right? This one's already, it's already kind of good if you look at it at exploring. They're gonna explain some more, so we're gonna check out. But that's the gist of it. So if we look at self-reflection, this one is it's a bit weird, right? So it's the count of question it's asking itself. Sorry, the count of like word that showcase self-reflection that the model is asking itself depending on the temperature. So like you have DeepSeek Math here, you have DeepSeek Base, you have Llama, and it's asking some of this question, some of these haha question, but not that much, right? But these ones, right, are actually asking themselves a lot of questions, right, that show these aha moment from DeepSeek. So this is all the Quen family, and if you look at it, right, what they're doing actually is like they have these keywords. So let's say check again, double check, go over the step, reevaluate, blah 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 blah. So they have this, right, and you can see like a bar plot of like each of the model over. Like this is the worst plot I ever seen in my life. Like what the fuck are we looking at, right? Yeah, I've no, like I think they will have. There's a better way to showcase this. Anyway, so like this is this. So there is some of these keywords that are being shown. I don't know how to interpret this. I will have to look at all of the colors one by one. But they also asked like a LM to do that, right? So this is the LM base detection, and this is the keyword base. So keyword is just like literally these keywords that they selected to be representative of the thing. I don't know. Like look, this one here, this one is for what? Is it for the reevaluation? Is it a mix of both? Right? What the? Yeah, I'm not sure. I think it's like maybe it's like everything around the tick is this one, and then this one is like everything around. Oh yeah, look here. There's this lines. Okay, no, it's not too bad. Yeah, but I'm not gonna look at all of the colors. Anyway, so like this is the LM based detection about like if they're in this regime of like asking themselves question, and this is just the keyword based detection. I see weird stuff here. As the temperature increases, like the judge is saying that these ones are like asking themselves more questions, but not here. They're like we see no count of these keywords, so it's something else that they're saying, something maybe more intricate. I don't know. So what they did was like they did a mix of both in order to get that right. This is what's happening, and then you get this this separation. It's a bit weird that like well, you can see the separation between like the Quens and the rest. Here a bit less pronounced for Quen 2.57b. But anyway, that's how they figure this out, and you get that. You get false positive also like on this. So for example here, the false positive for the keyword based detection is like it's gonna say all that, and then if not increase K and check again, and then like. But I mean, like this could have been good. I don't know. Like it's very subjective, like that self-reflection thing. And here it's like a one from the LLM judge that they're saying it's like it's not any sort of reflection. But if you were to give it to me, I'm not sure I would have said it's false positive. So that's the gist of it, right? This is what we're seeing here. So the Quen 2.5, if you look at the performance, right, with the template and without, you get these, right? So without a template, with Amy, you get like okay result, right? With the R1 template, you literally killed the model ability to answer, which is crazy, right? So I repeat, right? No template, it's doing good. This template, also doing good. This template, bad, right? Which is absolutely insane. Well, this is, I don't know, man. Like, there's not that much difference in my view about like these two. It's just like the way it's kind of like formatted that like is changed. Like, yes, of course, this one is a bit more strong. Maybe it's because of like the box thing versus the think tag. Maybe it's this. that like it was so already RL on it that like it's actually trying to do a thing and then get mixed up, and then like we can't extract the information. But you get like 0 result here, like absolutely 0. Same thing here, like very poor result. Here with the no template on the Amy 7B, you actually get a poor result than like with the Quen template. So Quen template was good here. And then throughout with the other benchmark, you see that no template is just strictly better, right? All across. So you've seen here, over there, something is going on with the Quen and the Amy setup, right? And maybe this is why like their R1-Zero from like this paper got such a big result. Amy look a bit different than like all of the other benchmark. But that's the idea, is that like if you use no template with Quen and then you just give it a question, it's good. It's kind of distilled or like constructed in a way that it doesn't like it's get maybe overloaded when like you give it a template. It's already good to go. It can just go and work, which means that like the Quen 2.5, something is up, right? It's not like the other ones, which like from a pure looking at the parameter count type of thing, you might not realize that, right? And you might not realize that like it actually is good. Like if you look at the performance, it's actually like compared to the other, one of the best. But like you can nerf it by using the wrong template over here, right? Even the 4-shot prompting, which I don't know why it doesn't work, right? It can nerf it by a pretty solid margin. Look at this R1 template all across. You're killing it, right? And I think it has to do with the formatting that it is in the think tag. Anyway, so this is their first, honestly, like the first, what's it, like a hint that the pre-training and the post-training stage are tightly connected. You have to literally understand each of the model you're using and how to kind of like work with it, right? And even like once, if you're not just post-training it and just using it as is, like the way it was trained and like the bias that it has before it get like pushed out has a big impact. So you should read all of the 60 pages report. that's the conclusion of this. Why do 4-shot prompting also throw it 0? Like R1 I would understand, but the 4-shot prompting, I don't know. It's like you just give it, for example, I don't know. Okay, DeepSeek V3 base, right? Also kind of is like a peculiar in how it's behaving, right? So just the V3 base, right? You already have the moment, even without the RL, which kind of makes sense, because if you like, as we understand a bit more RL, how it works, it does seems like it's more about like taking a capacity that is already in the model and then just making it more likely to be like outputted in some way, right? Like there is some crazy study that I've seen with Google at the Colm conference, where they literally were just like scaling the inference and then just doing a pass at like 10,000 or something, and it worked. You just have to verify which answer is right, and then you got your stuff. And it's highly parallelizable also, like doing it this way. It's just absolutely a crazy Google way of doing things, but this is possible, right? So the model actually is already capable of doing this stuff, which was pretty cool on the paper, like DeepSeek V3, DeepSeek R1. It's like, hey, wait, I'm overthinking, let's try again. And then like it just try again and it does the stuff, right? And here say, aha, I can use this to get, and it does the stuff. So these are the aha moment that like the DeepSeek R1 paper showed. It's just that they happen at a lesser frequency, right? So if you see here, this is DeepSeek V3 base, this is DeepSeek R1-Zero, and then you see a whole bunch of stuff. Breakdown of response category across difficulty level in the math dataset. So you see like DeepSeek V3 base is just like a bit worse, right? And DeepSeek R1 is just like kind of better. Like some of them are unformatted, which is like also kind of wrong, but it's kind of better in general in terms of green than DeepSeek V3 base. But if you look at the correct versus incorrect, this is where you have to like pay attention. In this micro table, look at it, right? Lean in. What do we see here? There's base unformatted less, right? R1-Zero unformatted more. Understandable, right? Correct less. Well, this is understandable. R1-Zero, correct. More. Yes, also understandable. Incorrect. Like we have these, right? This is like the this is the average response string, right? So unformatted, like there is a smaller unformatted output on average, right? This one is longer, which makes sense because it's just like thinking and thinking, right? So this is more, it's fine. Here the base correct response is shorter, which is makes sense, right? It does the answer and then like it's done. The correct one for R1-Zero also is bigger, which makes sense because it's like outputting like think tag and then just getting reasoning, right? But the incorrect one is 8 times larger in R1-Zero versus like the incorrect one. This one is kind of absolutely massive compared to this one also, right? So what are we getting from this is that when it's incorrect for a long time, like just spewing out token again and again and again, right? But like we RL'd it in order to like get this behavior, right? But like the correct one aren't as massive, right? It's like it's as if like it's okay for the model when it's incorrect to just go on forever. And I think you already might have seen like in some of these model this behavior where you just ask it like a nonsensical question like show me that 2 + 3 = 1 or something like that, and it just continue and continue and continue, and it doesn't stop. This is something akin to this, right? And we're gonna see it in a few. It has to do with like literally the GRPO algorithm. Another tidbit of interesting information is that this is the accuracy difference between response with and without. Accuracy difference between response with and without self-reflection for each question, and this is the average and stuff, right? And so this is on DeepSeek R1-Zero. So this one, right? They're trying to see like if you have these self-reflection thingy, haha, I can use 2 guess to get, or wait, I'm overthinking. Is there a difference in performance really, right? At the pass at like multiple, I think it's 32 or like something like that. And there are, again, use the LM as judge there to figure out in which category we're at. And what we're realizing is that there's not much difference in performance, right? Like it will just, like whether it's using self-reflection or not doesn't do anything really. So like this maybe is just an artifact, like it doesn't actually need these tokens in order to get to the right question, even though it's doing the reasoning stuff. So this is pretty interesting because that was a big claim in DeepSeek v3 that like, hey, this is important, it's using this and that in multiple direction. And I also covered another paper which like that thing was kind of important, and they're kind of changing GRPO in order to do that stuff. So like this is like claiming that like maybe it's not that important, and like because like you actually don't seems to need it, right? Well, this is for a base. Any question here before we move on to the other stuff? Big win for the LM aren't actually reasoning, folks. I mean, it still do reasoning. It's just like not. I mean, it doesn't. I don't even know what reasoning is at this point. Like, to be honest, folks, like, what the heck does it mean? It's just like going over the token again and again, multiple one, and then using that as an RNS to kind of say like other stuff that are more probable. In my view, like reasoning is like a flawed nomenclature, a bit like consciousness in the synthetic realm is like of course you're gonna get a whole bunch of debate about what is reasoning, what is consciousness, when you apply it to the thing that like it was not even defined to be the thing, right? And then it's just a guy that decided to call this reasoning, but we could have called it like anything else. Yeah, so like in all of these nomenclature debates, I don't want to have nothing to do with it. Is it spewing token more? Yeah, okay, yes it is. Like look, if you look at it, like is it actually doing it? Yes, look, like it's spewing much more token, right? And like is all of these token like a reflection token? Like kind of yes, no, not that much. There's some outlier. I don't like even the way that they've done it, this part of the experiment. I don't approve 100% of the result. I think there's different ways they could have done it. Yeah, even this part, right? Look at that. Look at this. LM based detection and keyword based detection almost doesn't agree, like on this whole result. Like, come on. I don't know. It's a flawed concept. I think like self reflection and stuff like that. When you apply it to these model that are more, I don't know. Like yes, they're saying tokens and stuff that we can interpret, but are they actually meaning it, right? That much. Like I don't know if you remember in R1, the R1-Zero was speaking in Chinese and like emojis, and it's reasoning tokens. Right? It didn't make sense, right? And then they had to kind of preference fine tune it so that like it is more like English like. So again, a preference fine tune it on like looking like you're doing self reflection stuff. I don't know. Yeah, that old part I'm not too sure. I'm more in the to be honest, I'm more in the camp of just let the model be weird. Like it doesn't like can we get to the actual output like proper and let's debug it. Like even if it start to speak Chinese and stuff, I don't mind. Like let it speak Chinese and its reasoning trace. Like who gives a shit? Like you're gonna read that, you're gonna read that, or like even if it does, maybe it means something, right? It's more than a programming interface in some shape or form, right? Like you look at the stack trace and you can debug it, and like you know that when it speaks Chinese, it is in this like specific mode, or like when you start to speak emojis, you know, like the answer will be a bit spicier stuff. Okay. Like there is a seahorse emoji bug. Yeah, the same thing. Seahorse emoji bug question. It's like it will start to spin up and like keep like saying stuff. Yeah, like thinking trace. Why you should analyze them? Like let them be super weird. Hey, biological capital and Twitter. Yes, the chat is live. Yo, what's up, man? Yeah. Yeah, it's live. You can chat here. Also on YouTube where I'm just doing the back and forth. Okay, so that's what we have right now, right? This is a setup. Studying the base, like what you should get out of there is that studying the base model and how they were constructed is absolutely crucial because it might literally kill your whole harness or framework or like evol that you're doing because you're using literally the wrong template, right? Or like like the base prompt that you're using is wrong, right? So if you go into the algorithm, right, this is where stuff gets wild, honestly. Like you're gonna see the full extent of how much like messy it can get in deep learning for like not messy in the sense like you know in software engineering like sometimes there's like you look at the code and like what a pile of trash, right? And then you have to dig into it and then there's like some bugs into it and then like you kind of like amass this. Imagine this but with just 5 lines of code, right? Because this is what we're talking about. It's not even that big. Like the GRPO algorithm is not like massive, right? It's a few lines of code, but like there's some element in this few line that will have massive downstream impact on like the behavior of the model, which is crazy, right? Like imagine you go into a code base and there's just 5 lines and you're like, okay, well it's good, right? And then you just move on, right? But like there's one thing in there that like will mess up some of the stuff and like lead to weird bug that you don't know what's happening. And when you dig into the literature, you don't see like this thing happening, and then you have to dig into like the code base from another run, and then you see that this is where they were doing that stuff, but it doesn't apply to your particular situation. So the problem is not in the code per se, it's in the context surrounding it, which is not apparent if you've never been into this context, right? So buckle up, right? So if you want to dive deeper into GRPO, I don't want this to become like a full-blown like derivation of GRPO again. You can check out this video that I made, GRPO and DeepSeek, and you'll see that like this term here, I didn't cover it because I didn't know like why it was there. I just assumed it's like a mean that you're doing like with the you get that it's sort of mean. It's actually not. It's kind of a normalization term that they're using for numerical stability, right? But this is from the DeepSeek math paper, right? So it says from PPO to GRPO. and then they showcase this this version of PPO, right? Which all looks fine. It's all good, right? You have the clipping over here that is happening from the TPO, right? So like where you constrain like how much you can move. Here, this is the KL divergent and the reward that will appear in the advantage type stuff that will go here, right? All good. But this one kind of went a bit unnoticed by many, right? And then if you go down the GRPO, like this is a GRPO formulation, it still hold this guy, right? The KL divergence has been shoved here, and then like this is how it's defined, which is totally fine. There's been, by the way, 5 ways of defining KL divergence. They just took one, which also is different from this one. So there was a lot of movement in this paper, but like this is fine. It's still all good, right? It's just this one divided by like the output length here that was a bit unnoticed, right? But if you look at the policy proximal policy optimization algorithm paper, so here, right? So this is from like the Schulman, which is also the one that like everybody is like referring to when we're talking about the KL divergent thing. If you actually look, so this is a trust region method. So this is where the clipping thing is happening, right? And then you go down into the actual formulation. So they put the KL divergence thing. The algorithm is this, right? It's like this stuff. And this is what they're minimizing. Wait a second. Yes, it's this, right? So this is the whole thing that they're giving. So there's the clipping stuff. There's like the other things that they're using here. There's the KL divergence. There's no mention at all of this one divided by the length of the output in any shape or form here, right? And you have like the actual algorithm. So everything is fine here. But this thing is coming from somewhere else, right? And now when like this is our guys from this paper are actually doing the derivation from this, they're taking the actual stuff from Schulman, like, and this is how it looks, right? This is like the actual stuff, and then like you can define it as to maximize the entropy regularized objective, right? This is what we're doing, and then you have the KL divergence over there, and then in this case they say we don't even need the KL divergence because of like how the reward is done, right? Say GRPO first sample a group of response per question and compute the return, blah, blah, set the advantage. So we don't need to be, oh wait, no, it's actually here. Yeah, here. This RL tuning reasoning model typically employ a rule-based verifier. This allows us to remove the KL term, which not only save the memory and computation required by this, but also potentially led to better performance for R1-Zero-Like training. Remember, the PPO, this stuff, right? As it was defined here, look at the experiment that they're doing, right? They're doing half cheetah and hopper type of stuff, actual RL type of thing. This is a bit different. It's like not the same type of RL that we're talking about. So they remove KL divergence completely, right? So it looks much cleaner like this, right? This is the PPO thing that they have. But look, there's no mention of the one divided by like this stuff that we had before. It's just gone. So what they did is just they reconstructed the GRPO with that in mind, right? And then they also used the advantage of all token, so with this like normalize in this specific fashion. And what they see is that this one and this one are a bit weird, right? Like this is the part that you can actually modify. And they said a notable trend is the consistent increase in response length throughout the training process. However, we argue that the observed increase in response length may also be attributed to a bias inherent to the GRPO objective function. And this is this bias. It's the one divided by the length. And then they had this nice experiment, right? Well, actually, this is just a nice visual. So you see here, so this is one question, and this is another question, and then you have multiple output, and then you create a group of output, and then you create your advantage based on this group of output, right? What you see on the first one is that, look, like this one is a medium length, big length, and then like small length, right? This one is wrong, this one is wrong, these two are like right, okay? So when you see here, you get like some sort of advantage that is good, right? So a reward. The longer one get a smaller reward, right? And then the small wrong one get a large penalty. But this one is the issue. Look at this. The large wrong one get a smaller penalty than the other one. It is just as wrong, and we're wasting much more token, right? This is the issue, right? So like this is super important. Like this is principally the issue. And if you look at another one, see like this one get a small penalty, even though it's like gigantic, right? But there's also another issue with like the amount of weight we should put into this question set, right? So if there's a large standard deviation, right? So like there's a lot of like big ones and then a bit of a smaller one, so it's like skewed. Wait a second. Wait. So if 1 divided by the standard deviation here, if the standard deviation is like super large, we're gonna get like a small modifier on that. If the standard deviation is super small, we're gonna get a larger modifier on that. So we're gonna like take this question set, right? This one much more into consideration than this one. That's what's happening, right? And this is the other term, right? So there is an effect from this term, and then there's an effect from this term, and they're having like different type of effect. Oh, in a nutshell, this is it. Wait, we have a question. I had no idea that it's interesting. The code is so small for this. I don't understand the math, but I've been starting to learn calculus. You like, honestly, guys, if you are kind of thinking that like deep learning is some kind of like super complicated soup of compute and whatever, like and like code, and it usually is not, right? Most of the code that is complicated is just like it's normal like software engineering stuff. The actual complexity in the deep learning code lie in the fact that the information is not in the fucking code in the first place. It's in the papers, right? That are all written by different people and all over the place. So that's the issue. And then you're gonna read something and it's gonna be weird and not gonna understand. You think like, you think you're absolutely stupid, but actually it's not. It's just that it didn't make sense at all. But we just went with it, right? Is this live going to be available to watch? Yes, POV Live. We're gonna be recording this, and you can watch it on YouTube. Okay, absolutely insane. A single division lead to a whole research exploration. Absolutely crazy. And like not just that, right? This single division lead to so much compute lost, because it means that if you're wrong, your model is more likely to spew out more token to get like a lesser wrong like penalty. It's absolutely crazy, right? So if you know you were wrong, the model knew it was not going to be able to answer and stuff like that. In 3 tokens, it will keep on going for like 1,000 tokens. So the model survived to have longer wrong answer. Wait, then what if you take the inverse? Do you incentivize shorter correct trace? Yes, it's exactly what's happening. Like the shorter correct one are much more. Look at this, right? The shorter ones have a bias toward like being chosen, right? The longer, shortest one don't, right? So it's a bit smaller. So they will prefer to have like shorter right answer and longer bad answer. And if you look at the actual result that we saw before, it's exactly what we're saying. Look, you prefer to have like shorter right answer than and then longer bad answers, right? But this was kind of hidden in the fact that like globally there's more like text being written because of the reasoning stuff, and then you need to talk to itself and then say, oh wait a second, blah 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 blah. All of this stuff is happening, right? But it has a bias toward that in general, just to spew out more. So this thing was hidden. Actually, we could have done way less wrong output here, and it would have been good. Like it will have get the same exact result, and this is what we're seeing in the actual result, right? See, this is the GRPO done right. This is GRPO without length normalization. This is GRPO without standard norm, and this is GRPO. And if you look at the average trading reward, they all get to the same thing. Like all of these little tweaks that you can do, it's the same kind of performance, generally speaking, right? But the impact will be much different. Like if you look at the training length, right, in terms of like, if you look at the response length here, you see that like the one with the green, so GRPO without the standard norm, and then the GRPO, the pure GRPO, these two, they have much more token that they're outputting in general, right? The other one, GRPO without the length norm, and then done right GRPO, like these two, have a smaller response length and kind of throughout, right? At some point they kind of stabilize. These guys, they keep on talking, right? So there is some increase, but at some point it's like, yeah, it's good enough. We know what to say, but like you're wasting this delta here, right? And you see the average benchmark score kind of doesn't change. Dr. GRPO kind of is as good here. There is some kind of difference here, but it's honestly, it's minimal. It's not like crazy stuff, right? So we're not talking about like improving the performance like crazy. We're talking just about like stop wasting some tokens here. We have some question. Is it possible that the model ends up figuring out the problem with time, so the time length give it the ability to figure it out? Actually, no. Like this, what they show is that it actually doesn't matter. Literally, like this, there's more time like being spent, and like if you look at the average benchmark score, actually like the other ones that are talking less are better, right? There's no difference much in the training reward stuff. It literally is this bias toward just talking more, and you can see it just in this diagram. It took me like 30 minutes to understand this, right? But go slow because it's packed with information. Go slowly, and you will see that like if you were the model and you wanted to have like to avoid the penalty, you would just always output more. And if you want to gain the most reward, you will always output less when you know you're right, kind of, right? Well, that's the situation. So you're gonna get this kind of disparity between the two, right? You want to be right. Otherwise, if you're wrong with the short message, you're gonna get penalized a lot, right? So you're gonna have a bias towards saying more in general, right? So the reasoning stuff, but then you're gonna just say as much as you need to be right. But when you're wrong and you're going to the wrong path, you're just gonna go, right? You're gonna go all the way, so to reduce this penalty. It's crazy stuff, man. And the other one, like this one, has an impact, but not as pronounced as the other one. It's something else entirely, right? And you can see it here. You see the red and the blue. So the red and the blue both. Sorry, the red doesn't have this standard norm division type of stuff. The blue has it, and there's not much difference in the performance, right? It's just there's something else going on with it. But the green has it, and like it doesn't help it that much. So there's two type of bias. So the response length bias. So this is by dividing by the length of the output that I'm talking about. So longer response are penalized less due to their larger length of output, causing the policy to prefer long-chain response among correct and incorrect one. So if you had to choose between like correct the many incorrect one, it will tend to take the subset that is the longest. The other one is different. So this one is a bit weirder. So this standard deviation type of stuff, so just normalization, if you think about it, right? It's nothing crazy. It says question with lower standard deviation, those that are too easy or too hard, with the outcome reward being almost all 1 or 0, are given higher weight during policy update. It is typically computed across an entire batch. Usually when you have that, it is in RL, it's typically computed across an entire batch. In contrast here, question level normalization results in varying weights in the objective for different questions, leading to a difficulty bias in optimization. So it just biased itself in terms of like how difficult it is in the situation. Yeah, honestly, this one is not the most important one. It's the other one that has the most impact over here. So if we recap, question with lower standard deviation. So as we see here, so the one that are lower, so this one has lower standard deviation, and they will favor this one versus this one. So among many output, right, the ones with like the reward that are kind of skewed up, right, will be much more favored than the one that are more kind of uncertain type of stuff. So again, gonna go with like the very hard ones or like the very easy ones. Yeah. I'll have to sit with this one out a bit and then try to figure it out. But you don't need to kind of kill it technically. You can still have it. It's just there's no need to have it in the first place, right? Okay, so if we look, this is good. This is good. And they did also like multiple run, right? So and to be able to check it. And what you see is that the Dr. GRPO is much better. and the average output length is also like much lower in general, right? And as you go more and more training, this is more and more true, right? The difference is higher and higher here. So that's what's going on. And what they did is that they actually looked at all of the open source iteration of this stuff, and they saw that like all of them were kind of biased, right? There's none of them that is unbiased. They all have this term, right? So TRL, Open RLHF, URL, Simple RL0, Open Reasoner 0, none of them were unbiased at all. So what's going on? Why we have that? What they're saying is that all of these implementation normalize the loss by response length. This formulation implementation misalignment was present even before the publication of GRPO. So it's not a GRPO thing, it's something else, right? And they say we speculate that the misalignment might originate from pre-training stage, right? Because right now we're in post-training, right? We're using the PPO and stuff to post-train, where all tokens are packed into a fixed length context and normalizing the loss by the context length and improve the numerical stability. So it's a numerical stability situation we're at. And this happens, by the way, like it happens a lot that like in scientific computing, you're gonna see a formula and then like fantastic, and then you try to implement it and it's good in theory, but in practice, like it just can't stop messing up. So what you usually do is you're gonna add a bunch of terms in there to not be theoretically right, but be numerically more stable. And then the situation where you're gonna be theoretically wrong will be kind of slim. So there's a trade-off with this. This is what's going on. Theoretically, it's not right. Numerically, it helped, right? However, in the oral tuning stage, typical implementation normalizes the loss by the response length, which is not a constant, introducing an unintended length bias. And in this case, you see here, all tokens are packed into a fixed long context normalized by the loss by the context length across like a gigantic badge. So in this case, like specifically, like when you're doing this, the normalization, like the context length is the same for all the outputs, right? But in our case, we're already seen it. It's not right. Like some output will have different length than others, and it's fine, right? There's different reasoning iteration each of these output, but throughout the training runs, because you're normalizing like this, you're kind of doing this bias. So in pre-training, you don't have this bias, so it's fine to do this for numerical stability. Post-training, you don't, right? You have this bias. So the change that you actually need to do, right? Because you still need to have this numerical stability. It does help, right? But you want to have it without messing up like your algorithm. So what they're saying is that kill this, but when you're gonna do the actual like PPO, like GRPO type of stuff in it, you can just use a global constant instead. And here they're using a global constant called max token, which is a global constant during the entire training run unless budget curriculum is enabled. So this is like how many tokens the reasoning trace can output at the maximum, right? So you're always gonna divide by this. So it means that like you're not dividing, but like the actual like length that is changing in each of them, right? You still have this term here, theoretically speaking, but it's gonna be like 1 divided by like the max token length, right? It doesn't change. So across many run, you still have the same thing. So you just bring this thing a bit down. And that's the story, right? This is what's up. What's going on with this little thing. We have some more charts here, right? For like the GRPO done right, and then the other GRPO. You see the output length is just much smaller. The performance, the reward is the same. The output length for correct is the same, right? The output length for incorrect is much smaller, right? And you see it's like pretty gigantic. So if you look at in aggregate, right, you don't get like this kind of continuous increase that you got. I'm gonna put it up, right? DeepSeek R1. Sorry, the kids are there, so they're absolutely wrecking the house. I hope the wife is managing this properly. Okay, here you see remember this. No, that's what this one. Yes, you remember that stuff, right? Remember that thing. So actually what we should be seeing here is this. We should see um, something like this, and then it should taper off. But the increased is the incorrect ones. Absolutely insane, right? Um, that's crazy stuff. Um, but maybe it won't like with the R1-Zero because it's so much bigger. Because it's 16 something, 600 something billion parameter model. It will be different. But like right now, what we're seeing is this: like the output length is actually increasing, and then whoop, not that much. So I think it would have an impact on this figure. Maybe with the bigger model, it will still look a bit like this. But I don't know. Like we have to check it. I don't know if in the Nature paper, I can check out the Nature one, right? Sorry, it's like absolutely crazy right now. The Nature paper. Wait a second. Can we download the PDF here? Yes. Do they have the GRPO stuff here? You see, we have the same figure, right? This is a Nature version, so it's like the one from February 2025, right? And if we look at the GRPO one, I think they removed it. For each question, GRPO sample, then optimize the policy. Tac. Yes. Oh wow, they actually removed it. They removed the oh nice, this is so cool. Okay, wait a second. So this one is this one, right? So this is what they had before, and this is what they have right now, right? And there's 1 divided by G, but there is no mention of the there is no mention of the 1 divided. Well, is it the same formula? There is no summation either. But there's no mention of the summation that they're supposed to do across. No, I'm not sure. But they're still doing the standard deviation stuff here. I'm not sure, honestly, guys. Maybe they forgot to do this, the other part of the summation, because it's supposed to be here. Oh no, wait. This is across the group, but this is for one output. There's just one. No, I'm not sure. Do you guys get it? Okay, I'm not sure of the syntax here. What we're looking at right now is the formulation of GRPO, right? From the Nature paper, which is the last one. And we're trying to take a look if like they actually fixed it. So it's here for each question Q, GRPO sample group of output O1, O2, OG. So this is this from the old policy, and then optimize the policy model by maximizing the following objective here, right? And in this case, they're minimizing this. This is the loss. But then this is the group, and this is for 1 to OI. So until now, I'm not sure, but like they don't have it. And if you look, the actual plot is looking a bit different, right? The plot is looking not the same as what we're seeing here. It's a bit different at the end. This is up to 10,000. It's still pick up, right? Maybe it's squished, I'm not sure, but this one is bigger, right? So they train it for a longer time step. So yeah, maybe it's good. Maybe it's like just a model that is just more gigantic, but in the smaller models that they train, we actually see this discrepancy. Actually, I'm gonna try to pull up actually what type of model they've used for that last part. It was no, it's not the llama here. They tested it on experimental setting. We use out. This is a 7B. I think it's a 7B model. Both GRPO and Dr. GRPO exhibit similar trend to DeepSeek R1-Zero, right? So they tested this on the OAT 7B model. So it's a bit different, right? Whew! Wow! But anyway, I think like there's some stuff that you have to get out of there is that like every model is kind of different, right? And then like trying to figure out exactly what's going on, especially with like the formulas and like what each of the things means. Sometimes there's stuff that come from numerical stability. Sometimes that there's stuff that comes from literally older code base that are repurposed, right? So this will have an impact, definitely. If we continue our little discovery, I think this is the last stuff. There's just two things that I found really interesting. So the template here, it will have an effect on like what's going on in the RL dynamic. So here we have multiple benchmark, and then this is on the Quen 2.5 Mat 1.5 base model, right? And then they're applying the different template on it that they're looking at, right? So the R1 template in different benchmark dataset will have different end performance, right? So the ORZ1 is the biggest, is the more complete one, but you still have like this green one, GSM 8K, and ASDIV is like the simplest like template, simplest dataset that you can think of. With the R1, you need to have like the best kind of dataset, the largest one. With the Quen Mat template, right? So it's actual template. Actually, it doesn't matter the dataset. You could get like this kind of reasoning format type of thing already from the get-go with like this, and this is like a very simple like a benchmark dataset. But with no template, you still get the same, right? Just no template at all. So the wrong template in some of these models will nerf literally the model. So you have to be very careful, and you have to understand like what actually they want to know. You see here the ASDIV is like 2000 question, and it's just basic algebra stuff. So plus, minus, multiplication, division question. It's nothing crazy, right? And then you can induce the reasoning a bit more here. Or like literally, not even with training, it's good with no template, right? But it get better with like the ASDIV one. And with the math template, like you just get better a bit here. But this first trough is the no template bias that he has that is impacting this stuff. Yeah, so same thing that you have to keep in mind is that like the each model is different, and then the Quen 2.5 they are kind of still cooking or stuff like that. There's also this one that I found really interesting, and it goes into the same direction, right? They tried to take the Llama 3.2 and make it Quen-like, right? So remember here this one, right? So Llama 3.1, 3.2, they have the same kind of dynamic. So this one, which it doesn't have this kind of effect of Quen, right? That stuff is not happening like Quen does. But they're trying to make it more like that, right? More like already have a bias for that. So when they fine tune it before, right, with like two data sets, we have FineMath and we have Numina QA. The base model accuracy through the RL is more pronounced, right? So it's kind of much more kind of RL light. And then if you look at the GRPO done right and then GRPO algorithm, there is some same kind of effect that we saw with the Qens before. So here I think it's the wrong ones. When you do Dr. GRPO, the wrong ones goes down in terms of like output length. The right one has more output, right? So there's like this bias that get removed. The GRP one, everything just get more. So the wrong one and the good ones. But like if it's wrong, it's gonna be wrong for less tokens here. This is a nice kind of I'd say it like a confirmation of the stuff that we've seen before. But this part is the one that is interesting. And wait a second, let me here we can clearly see that GRPO can produce a double increase phenomenon, potentially leading to perception that long chain of thought can also emerge on Llama model after math pre-training. Unfortunately, the increase of length might be due to optimization bias, which can be effectively mitigated by the proposed Dr. GRPO. So, like the pre-training that you do and make it better, like if you use GRPO, just a vanilla one, everything will get more wordy. But like if you use Dr. GRPO, not everything will get more wordy, and it will actually look like this, right? It will look like a nicer curve, as we've seen over here, right? Just a curve that is like, it's more, but like not crazy amount of more. What I wanted to chat with is the Numina QA one was interesting, because this is what made actually the model more R-like. So here we hypothesize that domain-specific pre-training will help RL. Hence, we adopted the Llama 3.2 3B fine math, which is continually pre-trained on the fine math dataset. We hypothesize that the Quen 2.5 model are likely to be pre-trained in concatenated question response tech. So they prepared a concatenated dataset from Numina Math 1.5 and continual pre-trained Llama 3.2 for 2 epoch with learning rate blah blah. We refer to the concatenated continual pre-training model as Llama this one. So the Numina Math version of Llama 2.2 is more like Quen. And when they do pre-train it and then do RL on it, right? It has the same kind of dynamic as Quen 2.5. So it's more information that like actually we kind of understood what happened with Quen 2.5. And it has this kind of weird behavior where the pre-training that it was done on it affected everything that is happening downstream with like the RL that you choose to have on it. So the template sensitivity, right? And also like the its general performance at being really good at like this question answering setup. Okay, we're getting there. So in terms of performance, well, we've already seen a bunch of it, but like they did a whole kind of sweep, and it's funny because like that part is like secondary in this article because it's not the most important thing. Dr. GRPO is actually good, right? That's what we're saying here. It's like if you're using it, it's actually pretty decent compared to the base model, of course, because you're doing like some post training type of stuff. But in general, it's just a better type of setup that you should use. So you're seeing a lot of like a open source library that is using like post training stuff for RL that is adapting more this kind of GRPO done right. But this is an old paper, so there's a whole slew of other stuff that you can do on it. I'm gonna start to review some of them like in the week, but that's the situation right now. So if you recap, right? There's a bias in optimization in GRPO, and then this one is the most important one. If you remove it, you kind of not get like this massive increase that you had before, because the output length for the incorrect one is much smaller one, right? Which is good. You still get kind of this increase, but not as crazy as it was before. However, in the actual DeepSeek one, we still see this increase. Is it because that they still keep this, but we're not showing it, or because like this model is just so gigantic that like it actually happened anyway, right? The correct one become larger and larger. You see here, like we even plateau over there with the R1-Zero const at 16, and they'll pass at 1 here. But I'm not sure. If you look at the actual formula, it's not too clear to me what's going on. It seems that they removed it, but I'm not too sure about what's going on here. They still keep the standard deviation here, so there's a bias for like hard and easy questions. But that's the setup. So there's this effect, right? And then the second thing is that the template on a different model will have a big impact, and you just have to be careful about that, right? You can literally kill your model performance for nothing if you give it the wrong template. And sometimes you're much better to give it like the no template than the wrong template. But this is specific for a certain type of model, so you should be understanding a bit more your model in general. And that's it. Any question before we stop this stream? So generally speaking, I think you should read it, right? I think it's a good one, right? It actually show you a few tricks and stuff, but how to say it, like it show you how messy it is, right? So if like I often get like these questions like, hey, I'm not understanding this formula and stuff, right? And like I can't do the derivation, I can't understand like each of the term. Buddy, look at this shit. This got into nature, right? Like we got to this point, and we're literally like wasting tokens for literally nothing, for like a technical debt. Well, that's even a technical debt. Like technically, like this was still fine in the pre-training stage, but in post-training was not fine anymore. But also, if you look at how DeepSeek is running, there is post-training and pre-training. Like all of the stage are kind of mushed together. Like look at this, right? I think you might have seen like this this visual. Look at this stuff, right? This is how they got R1 at the end. This one, like the difference between like it's not clear cut as like, hey, there's the pre-training, the post-training, and then there's the middle training, whatever. There's like training all across, right? So there's a DeepSeek V3 base. We're doing some RL on it. We get the R1-Zero. We sample some reasoning prompt. We jammed it over there. So we have a cold start chain of thought type of thing. We restart from the V3 base. Now we can get the R1 dev base, right? And then we're going to use it to do the same thing we've done here, but to do the rule, reward, and language consistency stuff. We're going to like use it to kind of do RL on like DeepSeek R1 dev 2, right? Which will be used to kind of get some a bunch of output prompt. So we have a non-reasoning and reasoning data set that we then gonna use to do supervised fine-tuning, not RL, on DeepSeek R1 Dev 3, so that we can be outputting a diverse set of prompt to then actually training DeepSeek R1. It's crazy, right? It's crazy stuff. Like it's not as clear cut as like pre-training, middle training, post-training. It's all messy and look like more like alchemy. But if you take this and you try to apply what they've done in this paper into like just a normal post-training on like Llama, which is much different, or Quen, which is also super different, you're gonna get some weird stuff, right? And especially if like, I don't know, like they're more close or stuff and you don't know how they were used, you might get like some surprise. So all this to say is that like there's a lot of in my view like a lot of gains in just being able to understand what's going on with these models. If you do understand their internal and how they were actually constructed, it gives you a better perspective to like what you're actually looking like. So if you're coming from like you've never seen like these formula before and you just look at them without all the surrounding context, it's gonna be hard for you to kind of do anything that is useful, and you're just gonna be lost because you're missing like 90% of the information, right? And a lot of the researchers are also like taking information that we don't have all data in order to do their research. So it can get pretty noisy and can get pretty chaotic. You just have to learn to kind of live a bit with this chaos and just go with it. Like it doesn't matter. And I think this paper is a good one to read, to check out and get the sense of this madness. But overall, I think it will get you a much better perspective about the state of RL fine-tuning and the base model in general. Cool. So thank you all. The link to the paper is in the description, and I wish you a fantastic rest of the week.